Hello and welcome to the DoneJS contributors meeting. Today is Friday, December 22nd, 2017. My name is Chasen Lahara, coming to you from Long Beach, California, where it is a cold 49 degrees right now. Joined today by a few people from Batovi. You guys want to introduce yourselves?
Hey, I'm Chris. I'm coming in straight from the North Pole. Actually, Erie, Pennsylvania. But if you have ever been to Erie, you know there's really no difference. So
Nice to see you.
Chris stole exactly what I was going to say where I was from.
Hey,
but
mine's colder. I guarantee.
I guess I'm from Chicago. Bah humbug.
Hey guys, I'm Manuel. I'm calling from Denver, which is currently like really sunny without lots of snow, so that's cool for me.
That's good. Nice. So today we're going to go through some demos of what we've been working on over the last couple of weeks. And then if we have any topics, we'll discuss. I don't know if anyone had stuff that they wanted to talk about, but we'll do it after demos if there is stuff to chat about. I'm going to go ahead and get us started. Let me share my screen. All right. So starting off the beginning of the week, I wrote a blog post, the December community updates. So we're changing how the community updates go out since we moved to a 6-week structure for how we plan things and the survey and that sort of thing. It just made sense to do these every 6 weeks instead of every month. It was always awkward to write the update for the previous month and have it dated in the current month, whatever. So anyway, these are going to come out every 6 weeks. In this one, I kind of highlighted the stuff that we've shipped in the last 6 weeks. So obviously, we've been talking a lot about CanJS 4.0 and the stuff that's in it, including can debug and can queues. There's videos that Justin and some people have recorded about how all of this stuff works. So definitely check those out if you're interested. They give like a nice look at the stuff that's changing in 4.0 and why it's changing and why it's a million times better. So that's all of the CanJS stuff. And then kind of at the beginning of the last 6 weeks, Matthew worked on a lot of DoneJS related stuff. So CanZone and Done Auto Render are a lot easier to debug now with some new things. I don't want to go through all of these things, but check out the post for sure. And he recorded a video about how to debug apps with Done Auto Render, so check that out. And then he also wrote a bunch of new guides for steeljs.com on these different topics. So if you haven't seen those, again, check them out. Links in the blog post, and I'll post that in the forums. And then talked about how we didn't run a community survey in the past week because we've been focused on CanJS 4.0. And we will run another one in 6 weeks. And then after we have 4.0 out the door, we're going to finish working on the stuff that we had originally set out to do, including adding some guides, and then working on making it easier to configure and understand CanSet. Also links to some projects that some people in our community have made, including a really cool demo built on ArcGIS. I don't know how you actually pronounce it, but the mapping stuff. And then a Bootstrap 4 CanJS library. Thanks to our contributors. And then if you're in Boston, Chicago, LA, or Silicon Valley, we'll have meetups in January. You can click on those links and check them out if you're in those areas. So yeah, definitely go through this to kind of get the inside scoop on stuff that we've been working on. And then also this week, I worked on updating all of our demos to all of our CanJS 3 demos to use the latest CanJS 3 features. So we've made improvements on stashes, binding syntax, and that sort of thing. We hadn't run our code mods on all of our example code. So I want to give a shout out to this using code mods documentation. We have a package called CanMigrate that automates and just makes it way easier to move code from, say, the previous binding syntax to the newer stuff. So transforming stuff like this into the more explicit versions. So these are super helpful in upgrading apps. It was super useful to me in upgrading our demos. And then there were just a few changes that had to be made in upgrading, in making sure that all of our demos were working in 4.0. It was very straightforward to go through once everything had been upgraded within 3. So I guess I just want to point one out. So in this demo, we have, actually, I'll just show the code. So in this demo, we have like a tabs components that has panel components within it. It's pretty straightforward. You click on the different items in the tabs component shows these different tabs that you can click on, and then the panel's content is shown depending on what you click on. And then previously in 3.0, you had to use this kind of @ symbol to have like a reference to a function. And this is simplified in 3.0 because we don't, like in this syntax, we're just passing the reference, and you would need to actually call it with parentheses if you like wanted to call that function. So that's not needed in 4.0 anymore. So something like that just is a lot more simple in 4.0 than it was in 3.0. So I think that's all I've got. Anyone have questions or comments about any of that?
I guess I kind of have a comment about that tabs widget.
Yeah.
Like we talked about earlier. Like, I don't know. I guess it depends on what you are trying to do. But at least my initial conception of how that tabs and panel would work is that they are almost like a pair, that panel is explicit. I mean, you could make it so that you could use that panel in like a, I don't know, something else, some other kind of widget, accordion or something. But I don't know. It's just like it's a. If you go back to what it looked like to use it, the fact that you have to pass that add panel, I get it, but I also hate it at the same time.
So I feel like, yeah. So maybe maybe this is something where we could come up with a better example, because you might want to like more closely tie a like tabs component in a panel component, so you don't have to pass functions.
Well,
that.
There is. Okay, so this isn't the other like in can component. I think there's like a tabs widget example that uses inserted to like go look up the parent elements view model.
Yeah.
Access to everything that way. I'm not like, this is me not saying like what we should or shouldn't do here. It's just like it's I guess this would fall on more topics of just like discussion. Is there a place, if we were to see this in like an example application, or someone was writing this and they did that other pattern where you're like going to use the DOM to go find the view model so you can connect these things kind of like not explicitly, would we be okay with that? Like most of the time I'm not cool with that, but for some reason this one where I feel like I almost want to make like a native DOM element, I'm suddenly much more cool with that.
Yeah, I understand that.
Like I'm okay with us like going around to make something that like acts perfectly like a DOM element. But there's state that has to be shared between those, but the user never sees that if they're like interacting with those DOM elements. Like they don't have to coordinate between that parent-child relationship, because the widgets themselves should just handle that. Do other frameworks provide that kind of thing? Like, is there like another, or do they keep it locked down? Because most of the time you want it locked down. You don't want that ability. I don't know.
I know in React you have the concept of contexts that can be shared across like a whole subtree of components. As far as communicating,
how do you get? You can just reference that context without having to do anything special.
There's something so like the top level component has to like create the context, and then it's exposed to every subchild
without having to pass it to every
yeah, without having to pass it. And yeah, you access it through like this .context. I haven't used it myself or anything, but a lot of libraries have been taking advantage of that in React.
Yeah. Okay. So it's like the same thing. It's like it's basically is it kind of like tied to the virtual DOM, and it's like you can walk up and get like the props or component on a parent or something? Is it?
No, it's more like so. Like in a Redux app, you can integrate a context, have it at the very top of your app, and then anyone can call like this .context that .dispatch or something.
Oh, so it's more like a singleton.
Yeah, a singleton.
So
but you can use it to communicate between different components.
But I imagine it'd be tricky if you had like two of the same tabs widgets that they would like have to somehow know.
Yeah, you would have like two parents you could be talking to in that case.
Yeah.
Unless they were unique trees.
Well, so that's what we use. Basically, the approach that CanJS has is essentially, well, what you do is there's the DOM, and then you can get access to view model from the DOM, and then you could do whatever you want. Like, you can use the DOM as, like, in some ways, the DOM is structure. Like a child node has a parent node. And I don't know, maybe in like CanElement, that approach becomes a little bit more okay. I don't know. It's just something to think about. I don't really have answers around it. It's just, it's like more, it's making your widgets more consumer friendly, I guess. It's like, we're going to be like, okay, fine, we're going to swallow all of this state and passing parent-child relationship. We're going to like handle that for you. Because we don't have to want you to have to do it every single time you would possibly use this widget. Because the loose coupling isn't worth it.
Yeah, I mean, it depends what you're looking for.
Yeah. I'm just wondering if that's something we should like document, I guess, too. Is like, hey, if you want to go down this evil path, like, but it's good for your users, maybe if you're like making a generic widget library, this avenue is there for you. Anywho.
Cool. Yeah, for sure. Justin, do you want to demo next?
Sure. So, I worked on a debugging guide. I kind of have to put the final like polish on because there were some things that I was waiting on, and I moved on to other things. Essentially, I guess it made me happy that this stuff exists, and I think this is stuff that has really, for the most part, only existed in the last year, and a lot of it is only in 4.0 that like we're kind of taking these debugging patterns more seriously, and we're gonna have a guide for it. And I try to make it so it's based around how you would think. It's like, oh, I have a problem. How do I solve it? Not like, what is the API and what does it solve? So like, oh, you got to debug can stash issues. Well, we kind of have two utilities. One is we're gonna have this like one is upcoming. We're going to be able to console log. There was the old canstash.log, but it's going to look a little bit different in 4.0. And there's a debugger. Okay, those are helpful. You know, things like, how do I know what caused some code to run? Well, I don't know why. Oh, I noticed this too, Chase. And it seems like these things are broken. Like the hash change only was allowed once.
I'll look into that.
Yeah. Let's mention that. So you want to debug when an observable event or update happened? Like, how do you know what caused that? Well, I made a little video for CanQ's Logstack. I think I'll try to make videos eventually once like this page is done for all of these, showing it off, because there's a lot of like nuance to understanding like how the tool works that text just doesn't show. Like, it's hard to like, how would you explain how to use like the debugger tools of Chrome? It's a little bit more visual than your standard like showing code and seeing what it produces. So I'm working on that. I guess I'm just really happy that something like this exists now, or can exist, because we have enough tools where there's actually like a I don't know, like it warrants a page that details all of them. So that's nice. And then the other thing that I just started working on is this technology overview. I kind of noticed that there's really not like a singular explanation of like how kind of the theory behind CanJS for the most part. And definitely, I was talking about this with Ilya, who works at Bitovi, and he gave a cool Bitcoin presentation and asked me like, oh, what could he do to improve it? And I, as a better critic than author myself, I was like, oh, you should have a map for, like you should give people like a map or some like a way of kind of knowing where they are in your presentation and knowing where they're going and kind of having the larger context. And I was like, oh, CanJS really doesn't have that at all. Like something that kind of puts a picture of how CanJS works. And so for the most part, I realized like CanJS is, I try to come up with a picture, and this is it, is there's these core observables that you define your logic in, and then there's utilities that just connect those observables logic to different parts of the browser's APIs or your like service layer, right? So you make your define map. Hopefully that's well defined and kind of unit testable, and hooray, that's really good. And then you use the view layer of stash, component, can/stash bindings to wire up that observable to the DOM, or you wire up that observable to your hash change or your push state APIs, or you wire up that observable to your models. And you'll have multiple of these observables all kind of connected, picking a path to connect to. So for the most part, it just kind of walks through, like I'm trying to walk through each one of those kind of connections and what the basics are of it. I don't know, hopefully this will be a helpful picture for people who are picking up the technology. And then other things, just in status, I made that how can observe works video, which I will stop before I start talking. So you can check that out on the CanJS YouTube channel. And then, but I forgot what it was that I worked on. It was, oh, I already talked about the other video that I made. So that's it for me. We have a few topics too.
Sweet. Thanks, Justin. Manuel, do you want to present next?
Sure. So I'm going to continue with the debugging theme. And let me share my screen here. So in the last contributors meeting, I talked about can debug and how to use log what changes me. And if you missed that, I'll encourage you to go and watch that video. I explain a little bit of the output and how it works. Since then, some of the output details have changed. It's just labeling and minor stuff like that. We did it to improve readability. But what I want to show today is actually how to make your custom observables if you are working on CanJS plugins, or if you just decided to write a custom observable for your application, how to make those work with CanDebug and be easier to debug. So the process can be summarized in like there are two main steps you need to do. First, to assign meaningful names, debugger names, as Justin has mentioned this a couple of times. And there is documentation in canReflectGetName, which is the method we use internally to get the debugger names for each of our observables. And here we describe some of the internal rules we follow for naming and how to actually do it in an example. So the part that I want to focus on is actually the second step, which is actually register how the observable interacts with others. And that basically means registering what affects the observable and what actually affects the observable. And let me actually show you the graph. This is one of the dependency graphs that I showed last week. And I want to show this because what you are actually doing with using canReflect dependencies, which is an internal package, is basically just drawing these arrows. You are registering the the relationship between two nodes. And it's important to do that for every node in the dependency graph, because in the current example we have, someone called log what changes me starting from the scope key data node. But it might be possible that that same person is interested to see the dependency graph starting from full name. So if the arrows are only registered, the metadata is only registered in the scope key data node, you wouldn't be able to draw the dependency graph starting from a different node. So there are
so basically what you're saying, the problem is like we don't have an independent list of edges. Edges are kept on the objects themselves or like their relationships. So if you're going, you can't like, you know, if something is pointed at, if you have a node that's pointed at by other nodes, you don't know it unless you have those other nodes. And because we don't have like a list of all edges, this is the problem.
Yep. And
really the problem is we don't have an iterable weak set.
Yeah, we can't tell what are all the nodes involved in the graph at a given time. The other thing to consider about looking when you're looking at this graph is that the arrow may come from, and in the example that I'm showing right now is from full name to this observation, but there is an implicit dependency going in the opposite direction. What I mean by that is, in this case, you can read that the person full name affects the observation, but there is an implicit dependency of the observation being affected by the person full name. And we register those dependencies using can-reflect dependencies, and there are mostly 3 methods in here that I'm going to talk about. And the get dependency data of is the one that returns the object that we are using to draw the dependency graph in this example. And these other 2, add mutated by and delete mutated by, allow you to register mutation dependencies between observables. So the first step that I mentioned, that we mentioned in this guide, is you need to register what affects the observable, and you do that by implementing get key dependency, the get value dependencies. So each of these methods return what is called an observation record, and Justin talks about that in the can observation and can observation recorder video. Basically, these are like the internal observables that a given observable uses to derive its value. So we have a simple example here of a custom observable that uses an observation to derive its value. And then in order to register this dependency, we implement the get value dependency symbol, because the observation is a value-like observable, it holds a value, and it returns a set of that value dependency. And get key dependency is used for map-like observables when you have actual keys. And there is another example in the documentation about how to do that. It's mostly the same thing, but the key dependencies return a register using a map, where the key of the map is the actual observable, and then that map points to a set of the keys that actually affect the observable we are registering. And then is the opposite direction, which is register the observable changes, and that's done with the methods that I mentioned before, which is add mutated by and delete mutated by. And these are the kind of dependencies that are not like internal, but happen when an observable sets the value of another observable. And there are also examples in the docs of how to do that. And yeah, I think that's it, unless you have questions.
Well, I guess the real thing, I think the important thing to understand is when you have an event binding, and you like let's say you have a can observe that's making full name, and it's going to bind to first and last property of the person. We need to know both that full name is derived from first and last, what we've bound to. But we also now want to know when first and last are bound to, they should know that they are going, there's like a graph, like there's a line the other way that we need to say first and last is going to change full name. So the way that we did this, and this was, I don't know, either smart or stupid, but I felt like it was smart because it was probably the easiest way of doing it, was essentially you decorate your handlers, right? Like you decorate your handlers with, so if I am going to bind, if I'm going to bind on first, if the full name observable is binding on first, full name observable is binding on first, then we add to that handler a little bit of information that says like, well, you know about full name. So that when first is going through like, hey, what do I change? It can look through its list of handlers, see a little symbol there that says, oh, I change first. And then I've changed full name. First can say I change full name because it has one of full name's handlers. And full name added that handler so it already knows. So essentially, like we use handlers which have access to all these things in the scope, but we like kind of decorate them more. So it's like, hey, you are changing this. Like this handler is associated with this other value because it's going to change it. So by doing that, we have that kind of bi-directional. We can find from every single node, we can see like the things that it's changing and the things that are changing it.
Yeah, actually, let me go back to the example. I think I can show. I actually wrote that in the docs, but I just forgot to mention in detail. There, in the current example that I'm showing right now is the one that we have a map, and we are listening to the food property and setting the value of my observable. So the first thing we do here is to register the dependency. We register that my observable is affected by some map food property. But these dependencies go, the way we register these dependencies is just in one direction. We want to be able to go the other direction, and that's what Justin was talking about. We decorate the on-food change. What I did in the example was just to extract that handler. Let me go back. This handler here, I'm just extracting it out to a variable, so it's easier to decorate it with what is changing. Basically, what I'm saying, hey, this event handler is mutating the my observable, is affecting the my observable observable. And that's how we can get the dependency graph for each of the nodes. Hope that makes it clear.
Well, so the theory behind all of this is mutations are an awesome evil. And what I think ideally CanJS could get to is no out-of-box mutations, but all kind of in-box mutations are kind of set up in such a way that we have like really good understanding of the relationship between all values in your application, and then like the log dependency changes, and we can do graphs and things like that that help people understand their application better. So this is a way, like if we make it so that any bindings that people do, and in some ways we could even make it so like, ideally people shouldn't have to bind on observables themselves, right, in a CanJS application. But internally, we're doing it all over the place. But internally, we can decorate essentially our handlers to say like, well, what this handler is actually going to do is this. And I think I put in one proposal somewhere in CanJS, which is like, what we almost need is like a meta. In some ways, it starts becoming kind of like streams, but they can mutate, which is to say like, I want to listen on this observable changing, and I am going to do this with it. And this do this with it is like encoded. It's not just some arbitrary function that can do anything in the world. Instead, you can like essentially generate functions, or there's some API that say like, and most of this would still happen internally, where it says like, well, when this value changes, I'm setting this other value. And that's encoded and then understood by the framework itself. And then we could like, I wonder if we could like eliminate most out-of-box mutations. Like mutations would go through can/bindings and things like that, or through like the observable, like the can connect or the hash change, you know, it's kind of connected, is doing mutations. But those are all in box. And, you know, we would do the bindings in such a way that like the bindings were well understood by the framework itself. I don't know. That's the idea there, though. Cool. Thanks, Manuel.
Yeah, thank you, Manuel. Chris, do you want to demo?
Yeah, I can. If we can go to a topic real quick, I got people over at my house and they're gonna make some noise. So if you want to do a topic real quick, and then I'll get back to it.
Sure. I can
Yeah.
I can do it if nobody else is going.
Yeah, thanks.
Yeah, for sure.
Because it's related to what I was just talking about. Actually, my two topics are totally related to this. So the first is I wrote a blog article just talking about like a little bit how I'm wondering if there's a like my theories on how CanJS could position itself a little bit differently, where observables and or not observables, but like mutations are terribly awesome, and they're very easy for people to understand, that kind of object-oriented programming. But in large applications, they can make, you know, it's like aspect-oriented programming, where you can have crazy things happen like at any time. It's very hard for people to reckon with and understand. And I just made an analogy that multiplication was really hard to understand before decimal places, or especially division was almost impossible in like Roman numerals. But then with numbers, how we use them, it's an easy thing. And I'm just wondering if there's a way to make like keep the benefits of mutations and avoid their drawbacks by heightening like the representational skills of software, essentially, to represent those things, to allow like the simple syntax of mutations and things like that, and kind of have like isolated state, federated state, but then you have the benefit of like you can understand it at the same time. I don't know if that's possible, but I think it's an interesting direction to take the framework, and the stuff Manuel's doing, I feel like, is a big part of that. And related to that was this property definition stuff. So like streams are one way of avoiding, and the connected, well, in 4.0, we're trying to avoid the events object, because the events object is kind of hard to test. Well, that's a big part of it. It's just, it makes it hard to test because you have to create the component to get the events object to listen to the view model properties and change things. So fine, we added can define stream kefir, right? But that's still kind of like a slap on to the framework. I mean, maybe it could become better. So James had some problems with all of this, and I talked with him through what is possibly like a middle ground, a middle way solution to solve maybe a bunch of problems. Not like, it's basically somewhere between streams and but it would still be on define map, and it's a little bit closer to like traditional CanJS event listening and doing mutations, but it works a little bit different, and that's this. And I just wanted to talk through this real quick because I don't know, I think it has some good ideas, but I'm wary of half measures. So just wanted to make sure people understood it. So if we discuss it in the future, people understand it. So the idea is mostly like there would be a callback. I actually implemented some of this. Let me see if there's let's just say you wanted to do the instead of using a getter and a can observation, you wanted to like implement full name yourself by binding on when first or this is supposed to be binding on when last happens and then deriving the full name value. Well, this is one way you could do it. You could make everything up here everything is up for debate at this point, the APIs, but the idea behind it is essentially there's kind of a connected callback when like someone were to bind on full name for the first time, it would get a resolve handler that can be called with the new value and a listen to that allows you to listen to other values, properties changing on your define map or your define map's properties. Like maybe there's a nested value that you want to listen to, and then you can call resolve with the new value. So this should be listening on first and last and resolving. You'll also notice that at least in this proposal, I wanted to make it so that it supports if someone called full name but hadn't bound to it, it's possible listen to and resolve would be undefined. It's possible to still provide a value, even an instantaneous value, even if you're not kind of set up the listening on it. Anyway, so the idea here is, you would bind and then essentially just resolve to your value. And this can handle a whole bunch of transformations that getters and setters could do, but getters and setters have mutations that are out of box. This resolve here would essentially be an in-box mutation, because we would know how full name is changing and we would know what everything you're binding to because it's going through this listens to. We would be able to set up all of that information to track dependencies the right way. So anyways, this is the idea. Are there any initial thoughts about it? I think this is something we're still going to discuss for a bit.
Yeah, I don't remember from what was posted in that issue or other conversations we've had about where we would expect people to use this in applications.
Everywhere that you would see a setter or a mutation, you would no longer mutate directly anything, ideally. So or where you're using, you could, so the thing is with this is this is basically like a stream, essentially. And it's like the weakest form, or it's like a stream without any of the nice APIs, right? It's like, Kefir has essentially they all kind of the same thing. I just know this one the best now. They all have a way to set up bindings here, and you get some way to emit values. And you listen to things and you emit values on emitter, and then there's a way of doing teardown. Now we don't need a teardown because the listen to that I would provide implicitly, and there would be also a stop listening, but we don't need as much of a teardown because when someone unbinds, we'll track all of these bindings and just undo them. So people probably don't have to provide this function, but this is a stream. And then Kefir also has another version where you can take a stream and essentially get the same function from the stream and derive whatever you want. So you set up your own listeners, you set up your own teardown. It's a little bit less memory safe, but as long as people are using listen to, it should be inherently memory safe, what this solution is. But yeah, all of that, anything where you could have used streams before, you could use this now. You could still probably use streams if you needed a bigger solution. But yeah, you would avoid setters and things like that. Ideally, we would warn people, even if they started using setters anymore, just say you should use this, avoid mutations, make sure everything's in box and is traceable essentially. So pros and cons to me, the pro for this is it's like, we're talking about like maybe like a half a K more of CanJS instead of like CanKefir. That's like, well, Kefir or some observable library just starts at like 5 kilobytes, and then there's the integration part, which might be another like half a kilobyte. It's a little bit less maybe error prone than the connected callback, or at least it's more organized than connected callback, I would say. It's also like easier to do in box. Like this listen to, like we'll decorate this listen to so that anything you bind to, we know that it's part of the derivation of full name. We know that relationship. It's a lot easier to do that where connected callback, like anything bindings can happen there. You don't know which properties, and there's still mutations happening. Like you're still setting properties in connected callback where this, you have to call resolve, which in effect is doing the mutation, but it's happening in box. So there's a lot of benefits to this with in terms of like the stuff Manuel's doing. It's just like, it's a half measure. It's like, this will get, if people have really complex derivations, streams are going to make that a lot easier. But I think it's, I don't know, it's better than connected callback, but it's not as powerful as streams. But is this like, this solves 95% of people's problems? Well, then that's really good. So I don't know. That's those are my topics.
Yeah, what I like about this is more closely locating the stuff related to full name in the full name property definition compared to what you might write with connected callback, where you've got an assorted array of stuff that you're updating in there. If that makes sense. Does that make sense? Yeah. So that's what I like about this. I feel like just looking at this example, it feels a bit much to accomplish that same thing, but I don't know. I like this general idea, though.
Well, this is, streams have a lot more, like streams would have combine or some other kind of, they have methods that can take two observables, get their last emitted value, and then you can return what the result should be. So you have that kind of, that power, right? Like, because there's like, there'll be like, Kefir has like 50 methods or whatever. We're not providing that here. So that's why it's like, it's going to be more, there's going to be more people have to write, but at least they can solve their problem. And is it worth, though, just, is it good enough where it's like we kind of say that this is the way to do it, and then, connected callback is kind of like, hey, that's there for really crazy things you might need to do, but this is really like what we start showing people.
So like, to me, connected callback is for a different thing. If we're talking about the lifecycle hook connected callback, is that what we're talking about?
Yep.
Okay, yeah. I didn't intend it for, when I proposed it, I didn't intend for it to be about property definitions. So I don't know if it's adding value to say that this is better, because they're for two different purposes.
What did you have connected callback for?
I had that for third-party ecosystem stuff, so they could bind on the whole object potentially, and then know when to unbind.
So you had like a view model that was getting called, and you were binding on you were binding on other things? Like
Yeah, well, this is going back to my type checking library. What I wanted to do was I wanted to watch for when any property changed, and then I'd rerun my type validations.
Yeah.
And all that needed was standardized lifecycle hooks, so I didn't have to set up inserted and removed in the can component that I
But
was
you're doing
using.
type checks on the property values.
Yeah, so, but it's all the property values. Like, I wouldn't put a type check inside of this connected for every single property. You know what I mean? Like, it's not a per definition type of mutation that I was going for in
Sure,
connected callback.
but that's what I'm saying. Like that, what you were going for is for when you maybe want to do something on the object as a whole. Connected callback is still valuable for that, right? But I think connected callback. I mean, there's the problem that I was looking for connected callback to solve, which it does solve. Connected callback, I see it as like a bigger, more general, can solve even in some ways more general problems across entire objects. But I still wanted that so that when people is a replacement for the events object. And a lot of times the events object was used to say like, well, I just wanted every time first was changing, I think they might be here. Maybe not. But like, just like if I wanted to count the number of times the application changed name, like I could bind to a name changes and set the name changed, increment the name changed property. I think that's still a valid use case for connected callback because you can't do that. The only other way to do that in CanJS right now is outside of the view model on the component. And then it's like you have this view model that only partially behaves how it should, which feels very wrong to me.
Yeah. Okay. I guess I understand why you want this. I will say, for anyone just watching, like when Justin says avoid the events objects, there's still like good use for it, specifically with delegated events and listening for event handlers. Those are fine. You know, don't go out of your way to force everything into the view model. Some things rightly belong in that events object. So
yes, absolutely.
Yeah.
Sorry if my mission to get rid of it for the view model might I might be overstepping or by over exaggerating or making people avoid it when they really shouldn't for those use cases.
Yeah, what we really mean is like for the lifecycle hooks for the actual view model, those should belong in the view model ideally.
I mean, that's the whole idea behind, like, as I'm writing up the CanJS technology overview, is that like your observables should be, that's where you define your application's behavior, and it should behave like the right way and be kind of testable to behave the right way, independent of any of these little connection things. So you shouldn't need a can component to make your define state and methods work the right way. And that's what you need right now.
Yeah.
And that's very bad. And connected callback fixes that. You can fix that with connected callback. You just have this kind of this method, connected callback, and as long as you call that on your map in a test or something, then from that point forward, you know, all of those, you know, name counts and things like that would change. I'm not saying this, by the way, I'm not, just to make sure, I'm not saying this supplants connected callback. Connected callback still exists. This would just be in addition to that. You would be able to have kind of specific specific definitions.
Mm-hmm. All right. Well, I mean, you know how I feel about stream stuff, so
yeah, I know how you feel.
I can't get too in depth. But yeah, so what I was trying to say was like connected callback is still good for the stuff that I thought it would be for.
Yeah.
Yeah.
All right. Cool. That's my topic.
Yeah. Thanks, Justin. Chris, did you want to demo?
Yeah, I can. It's quiet again.
Cool.
Got everyone over because it's holidays. Share. So I'm gonna
pull too, right? I bet it's a busy time of year.
Yeah, I mean,
lots of elves running around, and
actually, it's the most chill time. It's really weird. You'd think, but actually, all the work's been done for a couple months. We've just been sitting around.
Good project planning for Christmas.
Yeah, all we have to do is maintain the list of presents not to give out. But we always have enough in case everyone's good. But that never happens, so. Anyway, so what I've been doing for the past 2 weeks was moving forward. I did a presentation before I got pulled back onto client work briefly about can DOM mutate and where we were headed with the new API. So I've been integrating that, trying to get that in for 4.0. And there are just some API changes kind of in a few spots that I wanted to go over. You may use these, you may not, people watching, but everyone in this meeting is definitely going to run into it. So I'd like to go over some of the API changes. It's not going to be long. So it's at the very top, we have can DOM events. The only thing that has changed okay, so there are two things, but one just happened yesterday. The huge change to can DOM events is you used to call it with and util events, and now it's in its own package. And you used to call it with a dot call, where the div would be the context of the function. Now you don't need to use the dot call. You just pass the div directly into this. And that's really the huge change. The other thing is now delegate event listening is added to DOM events. It used to be mixin, that if you required it, it would just add itself on to DOM events. Now it's all the same, so you can count on add delegate listener being there just along with add event listener. I made that change yesterday, so it's not released anywhere. It is in a branch that I've been working in, but the reasoning for having add delegate listener inside of can DOM events is really just so we can more thoroughly test it and make sure it's working how it should. So I've moved over all the tests from can util that were covering these things, and they're all passing. So,
but well, to me, the big difference here is actually how you integrate custom events into it.
Yeah. So I could go over that too. But there are docs about that actually on canjs.com right now. But you'd have add event, default event name, and then you could override the add event listener with a function to do whatever. It will receive these same arguments. Like if I called this as superclick, it would get these exact arguments passed into this function. And then when you went to remove it using move event listener, this function would receive those same arguments.
And so I remember this is the registry?
No, this is the DOM events, because DOM events, you have access to DOM events .add event listener again if you wanted to, listen to potentially what could be another custom event. Like if you had like a, super click or whatever, it would go through the registry again. If you didn't want to have to go through the let registry, because that might cause an infinite loop, you would just, first argument is the element. So you would actually listen directly on the element using add event listener or whatever event, and that just works like normal. The other thing on DOM events is dispatch. That's been cleaned up. There used to be some optional things, but you pass your element and your event name or event type I guess everyone calls it that. So, so
Do you still
DOM,
control bubbling though?
yeah. So that's the second argument. I mean, third. But that's bubble true, and that's by default, just like it was in can-util. If you don't specify it, it bubbles, but if you manually set it to false, it won't bubble. So this same call in can-util's version, you would have to write call this, and then you also need this empty array, which is for arguments. That could be attached to the event as event args.
But we don't need that. That's gone now, right?
Yeah, no, you don't need. This is so this call is what you would do for can-util, but in can-dom events you don't need that anymore.
Can you talk to why we made this change of having this like registry instead of just doing the, before we were just kind of like overriding add event listener?
Yeah. So, well, first, like when we say overriding, what ended up happening was you'd have like in 50 different places old, and then you'd have a reference to add event listener, and then you rewrite DOM events add event listener with a new function, and then somewhere in between it might call the old one again. And what this so there are a couple problems with this approach. First of all, if you're debugging it, it's super annoying because you have to go through what ends up being, like a call stack of, 20 calls to add event listener, all overridden in different orders. The other huge problem is when you do this type of overriding, order matters. And there are a lot of issues where if you imported, for example, the inserted event before you required the remove event, there might be some different behavior based on how they're required, and override DOM events. So making this change, not only do you not have to go through 20 hooks of basically that were checks like event type, and then it would do if event type my type, and do something special for every single time you got a listener. Now in DOM events, it just looks like we have a register event type. Does it exist? So there's no turtles. It's just a check. Do we have a custom event or not? So that's only one check versus what could be 20 checks just for a single add event listener.
Yeah, I think the other benefit is that it separates like the event definition from the registry better, or it's possible to.
Yeah. That's another cool feature. That it's more additive than solving a problem necessarily. So, like here, I say default event name. In this, this is an event definition. By the way, when we say that, it's got a default event name, which means you can actually give this a brand new name. Like you could call it, mega click. And when you write an event definition, you handle for this case because you are provided the event type. So you can really name these events anything you want, and they'll still work as intended, which is really powerful because sometimes you want to add custom events, but you don't want to have to expose those to everyone else using the same DOM and the same DOM events. So specifically with my new changes, we have radio change, which really only exists to, property changes in can/binding to keep your view model in sync with radio buttons. And since I really don't want to expose that on the DOM for anyone to listen to because it's just needed for can stash bindings, what I can do is I can just give it a namespace. Can stash bindings radio change. And when it goes onto the DOM, now only can stash bindings can use that. So we can feel free to change that radio change behavior any way we want. Even though we're still using the DOM, we're not going to trip over anyone's toes. To me, that's really powerful because it solves a lot of things and it keeps us pretty safe from interfering with anyone else's code.
Awesome. Thanks, Chris.
Yeah, I had more if you wanted to. The DOM mutate stuff is also pretty locked down. Instead of using DOM events like we were, which has problems of its own, now you just say DOM mutate on node attribute change, and you'll be notified every time an attribute changes with the name, the old value. This is similar to the event you would receive when you just listened on the DOM event. And then when you're done, you just call this disposal method, and it'll clean it up. So you don't have to remember all the arguments like you would if you did a add event listener, remove event listener. This is like a subscription disposal pattern, which I think is pretty nice. Also, another change, it's subtle, but another long-term change to can DOM mutate is it used to be if you had an on-node insertion, once this callback ran, this binding would be undone. And the same thing for removal. Now that doesn't happen. Now we manually call these. And what that means is in the future, we can do really cool stuff where we can handle cases where a node is inserted, removed, or any pattern, and we can still get events. We don't have to keep rebinding to it as it flops in and out of the DOM. So really good opportunities there having this different API. And lastly, this change I've been working on. We haven't finalized it yet because it's just in a branch. But I think we're going to go with that you can see, like if you have an element in your dev tools, you'll actually be able to see this can.viewModel symbol, and that'll have a pointer to your view model. We have the package can viewModel, which will give you a function to read an element and get its view model. But this will probably be more helpful to people just casually looking it up, because now you don't have to make sure this function is in scope to actually see what the view model is associated with an element. So yeah, that's all the changes I have. I went way longer than 5 minutes, but
it was worth it.
All right, cool. Were there any questions about anything that was unclear?
I've seen all this stuff before, so I got it, but I was glad you could show everybody else.
Yeah, I feel like the last few things that you went over were pretty clear too. So,
all right, cool.
And I like it. So,
great. All right.
Sweet.
That's me.
Thanks,
then.
Chris.
Yep.
Do we have any other topics before we go? We're past an hour, but anything else? Nope. Cool. All right. Everyone who is watching the live stream or watching on YouTube afterwards, thank you for watching. Like and subscribe our channel and check out the links that are in the forum post that's linked to in the video description. And happy holidays, and see you guys in the new year.
Yeah, happy holidays, everybody.
Bye.
See you.